Flooding is a leading cause of natural disaster deaths and property damage in the United States. It's actually bigger than forest fires and earthquakes put together. Alongside flooding, communities in the U.S. are facing major ecological challenges, such as harmful algal blooms, polluted water, and degraded fish habitats. The aging flood prevention infrastructure adds to the problem.
Most of these systems meant for about 50 years of life, and we're well past that. Some of them are over 100 years old.
The threat of flooding is felt disproportionately by rural and low-income communities.
And typically that's because there's older infrastructure there. There's a lack of municipal resources to invest into upgrading those resources.
As storms become more frequent and intense, new tools are needed to help communities mitigate and adapt to climate-borne disasters. Huron River Watershed Council partnered with the researchers from the University of Michigan to find solutions to the challenges facing our water systems. They focus on Huron River Watershed in southeast Michigan as a case study.
Yeah, so the Huron River makes up 900 square miles. The main branch of the Huron is over 300 miles. In addition, we have 4 or 5 different counties that have components of the Huron River, and also over 65 municipalities that are within the Huron River watershed.
There's over 500,000 people that live here, so it is a highly urbanized watershed in parts.
We also have 17 dams on the main stem of the Huron, as well as almost 100 dams in total within the Huron River system.
Branko Kirkes is an engineering professor at the University of Michigan.
Our lab focuses on building technologies for water. In this particular case, what we're doing is we're building sensing technologies that can be readily deployed throughout watersheds and cities. These are basically cost-effective devices that measure water level. And you put these throughout a watershed, and all of a sudden you get a big situational awareness of not just what happened, but what's happening in real time. That can be used by first responders to sort of know where to go. And then secondly, we collect data sets for the long term that allow us to calibrate flood models, that allow us to look at the bigger picture and maybe start informing decision making and long-term planning. So the idea here is, instead of building more, could you repurpose existing infrastructure to squeeze more performance out of it, if you will? Where this becomes really interesting is when you're coordinating between multiple sites. So we can kind of imagine the scenario where you have a lot of rain in one part of the city, maybe not as much in another part of the city. And so then when we say is, hey, close this valve over here, hold the water, let the other part of the city drain out, and then kind of coordinate to release that water. And it's effectively like a self-driving car. It's making decisions about how to steer itself in real time based on changing conditions.
The river is impacted by a number of dams along the river that can alter the flow levels as you go along through the river. It's also altered up within the watershed in stormwater controls. My dream is that we have a fully functioning, real-time predictive network that we can then use that information to feed to all the people that are helping to manage the flow of water throughout the watershed, and to be able to do it in a more intelligent way, to make it data-driven.
Dam operators are key to managing water flow on the river.
The goal is to have the dam operators coordinate and communicate their decision-making process, so that way, as a whole, as a unit, they can make shared decisions that impact the whole of the river, rather than making isolated decisions that might just affect their part of the river. So I think that's where sociology and thinking about social networks and different tools that we have in the social sciences can help with that. My dream, or the next stage project, is to do a systematic examination of the amount of social capital that's present in the Huron River as it relates to the dam operators. So we would utilize a mixture of social science research methods to understand that, and to, in other words, map the network of the dam operators socially and professionally.
The goal is to grow the network of water sensors into a digital watershed. This will restore the river to a more natural state by enabling rural and urban dam operators to coordinate flows among each other. Researchers believe that these technologies can be scaled up to other watersheds. The lessons learned here may one day help to restore the flows of our rivers to natural conditions, while reducing flooding nationally.